Steps to graph. So here is the steps. Write this somewhere so you can remember. The first thing you want to do is find the pattern. And what I mean by that, you have to know if we're starting at the top or if we're starting at the middle. That's the first step. Okay. The second thing you want to do is find the start. How do you find the start? The parentheses equal to 0 and solve. Whatever answer you get, that is where you start. The third step is to find the end. Now your end is your period. The formula for period is 2 pi over b. Now, I'm making it simple for you all. In the past, we had periods of pi over 3 and 7 pi over 8. Like, we're not doing that. Period is either 2 pi or pi. That's it. Okay, if it's 2 pi, that means we're going to do 8 hops to the right. And if it's just pi, we're going to do 4 hops. All right, the next step is to find the middle or the midline. And that's really important because that tells you when you hit the middle, Jeremiah, can you put that away? That tells you where you're going to put the middle. And when we start graphing secant and cosecant, that's really important because that's your asymptote. So these are your 4 steps. Write this down, have it somewhere, because we're always going to follow these 4 steps. Okay? Okay, let's go ahead and look at our graph. So first step, we need to know the pattern. I'm graphing a sine. The signs start at the top or the middle. Who says it starts at the top? Who says it starts at the middle? Middle. Okay. So we're going to start at the middle. Then we're going to go to the top, back to the middle, bottom, middle. I'm going to write that over here. You don't have to, but middle, top, middle, bottom, middle. That's my pattern. Okay. Now we're going to figure out where do we start this wave. Okay. To figure out where to start, I want you to take your parentheses and set it equal to 0. I'm going to bring that down here so I have room. So my start is 2x. Is it minus pi over 2? Is that what I had in there? All right, set that equal to 0. And let's solve it. What's my first step? Add pi over 2. And then I would divide by 2. Dividing by 2, though, is the same thing as multiplying by 1/2. So I think I'm going to do it that way because if we divide by 2, we'll have to do keep, change, flip. That's doing too much. So what that gives me is half of 2 is 1. So x equals, and you multiply across, pi over 4. So that's where I'm going to start my graph. This is my start. So where it says horizontal shift, can you write that it's going to go right pi over 4? So let's go ahead and draw in that line. Keep in mind that we're graphing by pi over 4. So what I mean by that is the axis is counting by pi over 4. So pi over 4 is right here. This is pi over 4. I'm going to draw in my little vertical line. That's my starting wall. That's my starting wall right there. Now we need to figure out where to end it. The end is the period, which is 2 pi divided by this number here, which is 2. And what is 2 pi divided by 2? Pi. So my period is pi, which means to find my second wall, how many times am I going to hop? 4. So let's hop 4 times. 1, 2, 3. So this is where I'm stopping. Oops, let me use highlighter. That's my end. Sorry, y'all. Got a cold. I know it sounds bad. Okay. Now the midline. The midline is the same as your vertical shift. What is K? What's the number in the backyard right here? 1. So I'm going to go up 1. And I'm going to draw that in too. I'm going to draw in my midline. All of these lines that I'm drawing, you can draw these in if it helps you with your graph. All right, so I'm going to go ahead and fill in the amplitude. What's the amplitude in my domain? Yep, negative infinity to infinity. All right, so now that we have all this down, we're ready to get started. Whenever I say middle, you can think of middle as the midline. That's what that means. Sine starts at my midline, which is where I put my green line. So I'm going to put a point right here, right on the middle. And then I'm going to go to the top. When I hop here, I'm right here. How many times do I need to go up to get to the top of the wave? 1, 2, 3, 4. So you're all the way up at 5. Put a point at 5. Then I go back to my midline. Put your pencil here. To get to the bottom, from the middle, I go down 4. 1, 2, 3, 4. So I'm at -3. And I'm back to the middle. This represents 1 revolution. On your test a week from today, you have to draw 2 full periods. It's up to you if we want to count 4 to the right or if we want to count 4 to the left. Who wants to go left? Who wants to go right? All right, more people said left, so let's go left. And if you want to do right, do right. I'm just only going to do one direction, which is left. So if I go left, from this, I'm going to count 4. 1, 2, 3, 4. Put a line right there. So right here, this is where I stop. So where am I going to go from this point? Up, down, or am I staying in the middle? Down, because we got to follow the wave. So I'm going to go down to the bottom. Okay. And then I'm going back to the middle, which is my green line. Then I'm going to the top and back to the middle. This is my graph. And you can draw as many, you only have to draw 2. If you want to draw 4, you want to fill the whole graph, that's fine. But you have to draw 2. What's my range? What's the lowest that the wave goes? -3, good. And what's the highest it goes? +5. That's it. Any questions? All right. Let's go to the next one. Go ahead and copy it down. Same 4 steps. First, I need to figure out the pattern. Cosine. Where do I start for cosine? Top or middle? So top, middle, bottom, middle, top. Step number 2. Where do we start? Set your parentheses equal to 0. So my parentheses is x plus pi. And when I solve that, I get x equals negative pi. So I'm going to put a green or a vertical wall at negative pi. This is where I'm going to start. Now, because it's negative pi, that means that my wall went left pi. So that's what I'm going to write for horizontal shift. Left pi. Now, my period, is my period 2 pi or is it pi? What's the number in front of x? It's 2 pi. The number in front of x is 1, right? So my period is 2 pi divided by 1. 2 pi divided by 1 is 2 pi. So we need to hop 8 times. I want you to hop 8 times from my starting wall and put in another wall. All right, what about vertical shift? Down. Down how many? 2. All right, that's my new middle. I'm going to draw that in too. Okay, that's all we need. Now we know our pattern. We're going to get started. So I want you to put your pencil where your left wall, where you're starting in the midline cross. So right here. Do I stay there or do I go up to the top? Up. How many hops up do I have to go? 4. So from here, count up 4. 1, 2, 3. So you should be a positive 2. Now, whenever your period is 2 pi, we hop twice. All right, so I'm going to start here at 2. I'm struggling today. And then I'm going to hop twice and go to the middle, right on my pink line, because the pink line is my middle. And then I'm going to hop twice. And I'm going to go down to the bottom. So I'm going to go down 4. 1, 2, 3, 4. I'm at negative 6. Then I'm going to go back to the middle. I end at the top. So we have enough space to go left or right. This time I'm going to go to the right. So if I go to the right, leaving off here, where do I go now? Middle. Hop 2 times, go to the middle. Hop 2 more times, go to the bottom. Hop 2 times, go to the middle. Hop 2 more times, go to the top. Go ahead and connect that out. Try to make it curve. It should not be pointed. It should be a smooth curve. Oh, I messed that up. Hold on. I didn't hop twice. There we go. Okay. Smooth curve. That's my graph. If you want to go now, you can, because you have to go before 2. Okay. So what would be my domain? Negative infinity to infinity. And what would be my range? Okay. Huh? Brackets, because it actually touches that point. Alrighty. Now let's talk about the sister. And we're going to start with secant. Now, when we're graphing secant, secant only has 4 things that you need to give me. And the four things are period, vertical asymptote, which I'll talk about, and range. Those are the four things. And tomorrow we're going to continue practicing all four. We're going to just keep practicing. We got 2 more days, nothing but practicing graphing. Okay, Friday and Monday, graphing. Okay, the first thing you want to do is figure out who is the sister, because the sister will tell you if we're starting at the top or the middle. So who is the sister of secant? Cosine. So I'm going to pretend when I graph it, I'm going to graph it just like I would cosine. But we don't connect the points, and I'll explain why. Cosine starts at the top. So just like cosine, I'm going to start secant at the top. Then it's going to go to the middle, bottom, middle, top. The steps, the 4 steps that we had, that's the same 4 steps. So step number 1, find the pattern. Step number 2, figure out where you start. This is the parent function. So we don't have parentheses. So I'm going to actually start at 0. Because it's the parent. So I'm going to start at 0. And my period is 2 pi. So I'm going to end at 2 pi. So for this one, I'm starting at 0 and I'm ending at 2 pi. My period is still 2 pi. Now, the parent function goes up to 1. If you look at your unit circle, the cosine of 0 degrees is 1. So I'm starting at 1. And then I'm going to hop twice, go to the middle, hop twice, go down to -1, hop twice, go back to the middle, hop twice. Oh, I skipped the middle. Hop twice, go back to the middle, and then hop twice, I'm back at 1. And I want you to go the other direction. Let's go ahead and fill it in, go in the other direction. That's enough. So basically, I just plotted the points of cosine. That's all I did. Don't connect them. They do not connect. They don't connect. Yes. What'd you say? The negative 2. Oh, I put it too high. Thank you. I would have realized that when I finished it out. But thank you so much. I'm glad you're paying attention. Okay. So let's talk about it. Whenever cosine is equal to 0, remember 0 is the same thing as 0 over 1. We don't think about it, but 0 actually does have a denominator, which means the secant would be 1 over 0. What's the problem with 1 over 0, though? It's an error. It's undefined, right? Because it's undefined, that means we have a vertical asymptote. So every single time you're at 0, I want you to draw in a vertical asymptote. So I'm going to go, I'm going to erase this now because I don't want you to confuse that with an asymptote. Now I'm going to draw in my asymptotes every time it hits 0. So my first one, I'm going to put it here. Every time we hit 0, draw in the asymptote. So it's going to be every 4 hops. Every 4 hops, which is pi, we should hit a wall. Because secant is undefined. Okay, that's enough. Okay, now whenever we're at the top of the wave, which in this case is 1, it's going to look like a smile. And then when it hits the bottom of the wave, it's a frown. So secant and cosecant are just smiles and frowns, smiles and frowns. It's just going to keep drawing. Then I have another smile. If I go this way, I'm at the bottom, that's a frown. Over here, that's the top. And that's a smile. That's what it looks weird, but that's what it looks like. That's what the secant and cosecant looks like. So secant and cosecant, we do have arrows. Remember I said we don't put arrows on sine and cosine? But we do for secant and cosecant. Yes.
Does it matter where the like arrows are going?
Wait, one more time. Does it matter who?
Does it matter where the arrows are going? Like how close they are?
As opposed, they can only go up or down.
Is that how close they are?
Oh no, I'm not that picky. I'm not that picky. It should be close to the wall, but I'm not that picky. As long as you have a smile and a frown, I'm good. We're gonna keep going. Okay. So now let's answer our questions. The first one is vertical asymptote. My first positive vertical asymptote is right here. And what does x equal right here? Pi over 2. And then what's the distance between my asymptote? 4 hops. And what does 4 hops represent?
2 pi?
Not 2 pi, but what? Pi. So our vertical asymptote, we're going to write, starts at x equals pi over 2. And then it's plus and minus pi n. And the n represents it repeats. That's why we put the n there. N just says it keeps repeating. Every 180 degrees, we have an asymptote. That's why we put n. My domain is all real numbers, but you have to say x cannot equal, and you have to write the same equation you put for your vertical asymptote. That's my domain. Yes. At the top of the wave, it's a smile. At the bottom of the wave, it's a frown. So for secant and cosecant, it goes asymptote, smile, asymptote, frown. I think you were gone. When I do the next one, you'll be able to see it. Okay. Lastly is our range. Yes, Junior.
How do we get period again?
Period is always 2 pi over b, which in this case, b is always the number in front of x. And for the parent, it's a 1. Good question. All right, now let's talk about ranges. We have 2 different ranges. First, let's do the range for our frown. For my frown, it's negative infinity. And then where is the top of my frown? What is the y value equal right here? So it's negative infinity to negative 1. Bracket on the negative 1. Union. Now for my smile, the lowest point is positive 1, and it goes up. And that's it. So we're not going to do cosecant today. We're going to do another secant, but now let's apply some transformations to it. So let's look at, go ahead and copy this one down. So we got 2 secant, parentheses, x minus pi over 2, closure parentheses, minus 3. Okay. First thing first. This is secant. The secant start at the top or the middle. Who says top? Who says middle? Who is secant's sister? Cosine. So it's going to follow the lead of cosine. So let me ask you again. Cosine. Where does cosine start? So the pattern that I'm going to use is top. Let me go to the right. Hold on. Top, midline, bottom, midline, top. That's first of all. That's step number one. Step number two is to figure out where we started. So my start, that's going to be at, go ahead, take your parentheses, set that equal to 0, and solve it. So x minus pi over 2 equals 0. So we have to add pi over 2. Sorry, I need a cough drop. My throat is on fire. So I'm going to start it at pi over 2. So that means I'm going to go right pi over 2. Now, I'm going to draw in my wall like I normally do, but I'm going to erase it. Okay, because I don't want you to get confused with asymptotes. So this one is going to start at pi over 2, which is right here. What's the period? 2 pi, because the number in front of x is 1. So I'm going to hop 8 times to get the end. We're going to leave these blank until we finish it. Where is the middle? -3. I'm going to draw that in. The midline, this is important. The midline is where secant and cosecant are undefined. So let's go ahead and graph it. So put your pencil right here where they cross. Now this 2 still is amplitude, but we really don't have an amplitude. But right here, do I stay here or do I hop up 2 times?
Hop up 2 times.
Put a point right there. Then you're gonna hop 2 times and you're gonna go to the middle. You should be on the midline at pi. And then you're going to go to the bottom, which is -5. Hop 2 times, you're back on the midline. Hop 2 times, you end at the top. Now I want you to go this way. So from here, where am I going to go? I don't have any other choice but to go down, right? Because I'm at the highest point. So I'm going to go down. I'm on the midline. Then I go to the bottom, back to the midline, to the top, back to the midline. That's enough. We don't have to keep going. Okay, now that I have that, I'm going to erase the lines I put there. Well, I'm not going to erase my midpoint, my midline. I'm going to keep that. My midline. Every time you put a point on your midline, that is an asymptote. So I want you to draw in your asymptote. Anytime you're on the midline, you have an asymptote. So let's go ahead and draw those in. So for me, I made my midline a light blue line. Every time I put a point on the light blue line, I'm drawing in a wall. every time you have a point at the top, which for us, the top is -1, are you going to draw a smile or a frown? A smile. And then the next one is a frown. Then it's back to a smile. Then it's back to a frown. That's your graph. Yes.
When we draw that happy and funny faces, they then punch the line, right?
No. They should get really close to the wall, but they should not cross the wall. Okay, so let's look at our vertical. Yes.
So like, you don't have periods 4 or 5.
Uh-huh.
It would be like 8.
Mhm.
Go like back.
Why wouldn't we go back 8? You could. I just did my pattern though. But you could go back 8. Yeah, I just like, because once I know my pattern, I just keep going. But you can draw as many walls as you want to. Okay, my first vertical asymptote is right here, which is x equals, what is x equal right here? 0. So my first vertical asymptote is at 0. Then it's plus or minus. You see how we're going 4 hops? And 4 hops is what? Pi. So it's plus or minus pi n. Some professors put a k. You can use n or k. It just means it repeats over and over again. So when you write your domain, I want you to say, it is all real numbers, but x cannot equal 0 plus or minus pi n. Now let's do our range. The frown is coming from -infinity and it's stopping. My frowns come from the bottom and they stop here. What is y equal right here? So it's -infinity to -5. Put a bracket on that -5. Union. Now let's do our smiles. What's the y value for the bottom of my smile? -1. Bracket -1 to infinity. And that is your graph.